Namaste, welcome to Sthitu channel. You are watching Apache Spark Masterclass. And guess what? We are finally in chapter 3 for all those people who are eagerly waiting to get their hands dirty. Well, you are going to get it really dirty. Trust me, your hands will pain by the time you finish this course because you are going to code non-stop. I'm going to give you classwork, homework, and so much more stuff. So let's get started. This chapter is your hands-on guide to getting started with Apache Spark. It begins by introducing the core tools for interactive data exploration, focusing on the Spark shell for quick prototyping in both Scala and PySpark. Let me make this clear. I don't want you to complain about this in the chat or comments saying that I am repeating few things again and again. Yes, I am doing that intentionally. Most of the audience for this course is people who don't have hands-on experience. So when you are doing it for the first time, you have to do it again and again. Why? Because I'm trying to replicate real world scenarios. Like if you are working at an office, it's not like you are only going to develop a single application. No, you might not might you will write the same code for different applications again and again. So don't think that I am repeating some of these concepts again and again. Where the first time you will only grasp maybe 10% of what I am telling you. So when I repeat the concepts in this course again and again, by the time you finish the course, they will be engraved inside your brain. That is my goal. So uh, don't think that I forgot to I forgot about not covering a certain concepts or etc. So that is my plan. If you don't like it, I guess you have to deal with it. But that is because I have a way of teaching. I mean, at least I teach the way I learn something. If I were to learn Spark from scratch now, I would prefer that approach because I'm a person who likes to, not likes to, but I don't, if I read a book, I only grasp 10% of it. So I read it multiple times so that I will grasp maybe 80% of it. So that's the approach I'm going here. So uh, don't say anything bad in the comments. You will write and run your first Spark applications, learning the basic syntax and concepts that underpin all Spark jobs in this video and in this chapter. Next, the chapter moves from simple examples to practical business oriented analytics. You will use Spark to answer common business intelligence questions such as calculating daily activity users and analyzing average cart size. The chapter also covers foundational text analytics, showing you how to process and derive insights from raw text data, including the classic word count example. Finally, you will go behind the scenes to understand how Spark executes your code. The chapter breaks down Spark's execution model, explaining the relationship between jobs, stages, and tasks, giving you a deeper appreciation for how Spark efficiently processes data under the hood. By the end of chapter 3, you will have the foundational skills to write, run, and understand your first real world Spark application. So, are you ready? Now, that's the overview of the chapter. Since it's the first episode, I had to give that. Now, welcome to episode 1 of chapter 3. We are diving into the hands-on side of Apache Spark, specifically in this episode, the Spark shell. Whether you code in Scala, Python, or R, Spark shell is your gateway to interactive data analytics, quick experimentation, and rapid debugging. In this video, I will walk you through everything you need to know to get started, including some live code examples. Stick around to the end for tips on configuring Spark for maximum performance. We have, I don't know if we covered, but what is Spark shell exactly? Right? So, what exactly is Spark shell? Think of it as an interactive playground where you can run Spark commands. then test ideas, and maybe want to see some instant results, just like a calculator. But for big data, Spark offers shell utilities for several programming languages. We have already seen some of them. What are they? For Scala, yes, it's Spark shell. For Python, yes, it's PySpark. For SQL queries, it's Spark SQL, and for R, it's Spark R. And for running entire applications, you cannot use this. Instead, you would want to use tools like Spark Submit, which we have seen a couple of times. Also, there is something called Run Exam. Let's check out some real examples, shall we? For Scala and Java examples, let's do this. Let me echo my what is this? Spark home. Oh, yeah, it's not set. So remember, we need to run Spark notebook, which will open Jupyter notebook. I can close that, which I don't want. Or I can keep it like that. That's fine. So let me cancel this. Yes. Okay, now you can see my Spark home is set. And once you did do that, let's go to bin. Or actually, since my Spark bin is already set, I can just run this. Run example, just like Spark submit, I said, right? We already have some built-in programs. Okay, it didn't find it. So let me cd to Spark home, cd bin. We don't have the run example in, oh, we do have it. So it just didn't figure it out. Maybe I have Spark in my path, isn't it? That's fine. Okay, since I'm already here, let's run this. Serious? Okay, how about, yeah, let's run it like that. What do you think this is going to do? It is going to calculate my pi value. Basically, that's what this does. But it is an example that is already out there with us. What did I run? I will show you the command again. Spark Pi is the program, and it is run using run example. And let's look at this. This is for Scala and Java, and let's look at some Python examples. Same program we have in Python examples as well. You can go into the examples folder to find more of that. I don't think examples will be here. Yeah, I don't think the examples folder is here. I think it will be in here. Yeah, you have the examples folder here. So let's do this. Spark submit, and then exam not dot back. So we are going the folder back, and then run examples, and under it src main, and then we have the Python. Then in the Python folder we have Py. You can go and check that code out as well, how what they wrote and how they wrote, etc. So let's look at it. What is this complaining about? It's, oh, okay, we don't need this for the Spark submit, I guess. Okay, no, we do need it. But why? What is it complaining? It's complaining about Jupyter. I don't want. So okay, I think we have configured in such a way that don't whenever we execute Spark submit, I think we told it to open Jupyter. I guess that's why it is complaining that. Is that it? Yeah, basically that's what it is doing. I think that's what we configured it to do. Okay, so all right, no worries. We know where we have set that. So let's go to our bash rc file. And these are the two commands that are making it invoke Jupyter. So let's comment that out so that in future we don't get, when we want Jupyter, we can come here and modify it. That's not a big problem. Once you do that, Since we already set those variables here, we need to unset them. So go ahead and run this. Now these are unset and they're not pointing to Jupyter anymore. So let's go ahead and run our Spark submit. Make sure you are in bin. For some reason, my Spark bin is not in path. Let's check why that is happening. Okay, interesting. Nowhere I have added. Yeah, I added it here, but that is only for PySpark for some reason. So let me. No, this is not even in the path. So let me add this one in the path as well. So let's go here. Let's go there. Instead of executing this I mean, I can do that. It's fine. It doesn't matter. I think this will fail. So let me cut, paste. Path, Spark home bin. Okay. Now let's go ahead and run our notebook. It won't trigger notebook now. Instead, it will trigger Spark because that's what we told it to do. But I don't want that. So now if I just go, I should be able to run Spark submit from anywhere. So let's still echo dollar. Let's see if it has a Spark bin, Cassandra, Hadoop. So it's not even going there, I guess. When you run this, I guess it's getting stuck somewhere here. I guess this one. Yeah, now it should be fine. Let's go ahead. Source.-rc. Okay. Now this should be fine. If I hit path, it should show me somewhere Spark. Okay, here we go. This is good. Now let me run this and it should be able to run. So, okay. Okay, this is one. Another thing is these examples are not there anymore. These are in Spark. There you go. Yeah, since we have put Spark submit in the bin, we don't need to give that. Just run that. And here you go. We have got the pi value. So what did we do here? We ran the pi program. If you go to home and if you go to Spark, there are examples and source main. You have all kinds of examples here. If you go to Scala or Apache Spark examples, we have run Spark Pi, the Scala program. You can go and check it out how they coded it. I mean, when you are getting started, looking at already existing programs will really help you. Okay, so I would highly recommend you to check these programs out to see how. Yeah, these are from actual Spark people, right? So you will get an idea of how to properly code these things. So I will highly recommend you to check those out. But I'm interested in Python one that we executed just now. Here is the program that they wrote to get the pi value. You can go check it out as well. So create Spark session, then write your code and then give that value for us. All right. So those are two examples that we have seen. How about R as well? We have seen Scala, Java, Python. How about R? Let's do the same thing. Spark submit. Again, Spark examples, source, main, R. Yeah, it is R. Data frame dot R. Let's run it. Okay, we have a failure. Why? Okay, it is trying to connect to our HDFS for some reason. Let's go. Yeah, it is trying to connect to our Hive, whereas our Hive was causing so many issues for us recently. I think we have configured. Oh, yeah, makes sense. I wanted to show you guys this how to connect Hive to Spark, and I copied the Hive side file to the Spark. No wonder why it is trying to connect to that. You know what? For now, let me go ahead and delete that. I have seen this issue arise during our. Maybe I should have checked it. At that time, I thought some other issue. So I went ahead and started HDFS and Hive, but we don't need to right now. When we want to connect to Hive, we can do that. Um, what I did was I copied the Hive site, so that's why it is automatically trying to connect to Hive. Okay, you should not have that issue because I did that off the camera. So now it should not try to connect to Hive. Okay, it's still trying to connect to something else. Let's see. Okay, I don't see that Hive error anymore. But what is it trying to do? Virtual box to local host. Why is it trying to connect it to local host? Okay, let's scroll down. Okay, it's trying to connect to that for some reason. So basically what is happening is if you see somewhere here, people.json, this is trying to um, use Spark structured streaming file stream sync, which you can see here. So Spark is trying to contact a Hadoop cluster on this one. We have already established that. Where is that? Here, right? But we already know that my HDFS is not running. That's why it's failing that, because I have set the default file system as HDFS localhost file system. So, I mean, there are other ways to do it as well by explicitly giving the file location and whatnot. Um, do I want to do that? I'm just thinking. Or should I go ahead and tell Spark to use my local FS by default? Okay, let's go ahead and do that. How do we do that? We go to here and we are already in the conf, and here rename that, at least for now. I mean, we already have HDFS, we can run it, but at this point I don't want to complicate things. What if you didn't install HDFS? How do you want to do it? So you should still be able to do it, right? So let's go ahead. So now once you set this up, Spark should not try to connect to HDFS. Instead, it will see this and like, oh, okay, you set it to the local file system, so I will use this instead. Let's hope it will do that. Now let's go ahead here and run this. Now, as you can see, it didn't try to connect to HDFS. Instead, if you see, it ran it and it print the output as one Justin. Got it? So that's another example. I think these examples are good enough. Don't you think so? If you want, you can go ahead and run a couple of other examples that are out there. Check it out, play around with it. But basically, these are examples that are already provided by Spark. Okay. Now, whatever you did it using either run example or Spark submit. Now, let's learn how to use Spark shell. How do you launch Spark shell? If you already added Spark bin in the path, then just type Spark shell, then it will take you to the Spark shell, right? If you haven't set it, then you need to go to where you install the Spark, then go to the bin directory, and in there you will have Spark shell, then type Spark shell and it will take you there. You will see welcome text and prompt that looks like this. The Spark shell creates two important objects for you automatically. What are those, Sitapagnas? One is the Spark, your Spark session, which is the entry point to Spark SQL and data frames. In your code, you can use Spark dot, right? You can see that here, Spark session. You can write Spark dot and anything. And it also creates SC, which is your Spark context, which lets you access lower level Spark features. Spark session, it is the entry point to Spark SQL and data frames. SC is Spark context, which lets you access lower level Spark features. Why am I repeating? Because these things will be asked in your interview questions. You can check their types, the Spark type and SC type. How do you do that though? Well, you can type something called type, and what are we checking? Spark. And it is telling you this is Spark session type. Let's repeat the same for SC, and it is telling you it's Spark context type. Got it? Now, do you want to see an environment variable from here? This prompt, instead of going back to your regular bash prompt, you can do that. It's very easy. For example, if I want to know in which directory I am in, what would I do? I will type pwd. But what if you are in this prompt and want to see that? You can do that as well. That's it. This is common, and whatever command you want to run, you will put there and run it. It gave you what? Home directory. Sometimes if you want to know so that where you are reading the file from, you can use this command. Instead of going to that, you can run just that from here. And if you want to know all the things or different commands that this has, run help, and it will give you different options the Spark shell has. And Spark shell, you can run Scala code line by line. You can launch Spark with all sorts of custom configurations. For example, if you want to use Yarn as a cluster manager, or you want to allocate memory, or you want to add extra packages, you can run Spark shell, and then you can give commands like master yarn, deploy mode cluster, and then you can give driver memory, executor cores, and so many other options. It looks something like this. Let me show you this in a notepad. So you can tell Spark shell, and you can tell my master is yarn and deploy mode is cluster. My driver memory is that much, executor memory is that much, executor. Don't worry about all this. We will learn as we go. But the point I'm trying to make here is you can run Spark shell with so many other parameters like this. Right? This command, it sets everything. Cluster type, memory, number of cores, even adds the hoodie package. Now you have this. Why don't we do something fun? Let's create a simple data frame in Scala. How do we do that? Let's import Spark implicits. If you click tab, it will give you that. And you are doing underscore, not here, dot underscore. So you are literally getting all methods from this particular module implicits. Then what are we doing? This is Scala. And by the way, don't worry about how we are writing the Scala program, because I think after this chapter 3, we have a Scala Essentials course, and we also have Spark Python Essentials course if you are new to Python and Scala. I don't want you guys to be confused by looking at this coding. That's why I have those two. If you want to watch them before Chapter 3, it's up to you. But since chapter 3 is all about writing your first application code, I don't want you to concentrate on the syntax of the code. Instead, I want you to learn the structure of it, how you would write your application. That's what my main goal here is. So don't worry about all these functions, syntax, and whatnot. Just like Java, you need to tell the variable you are creating it. That's why we are saying, well, in Python, you won't, because Python assumes based on the data that you are putting in that variable what type it should be. So I'm telling my cars will be a sequence, and I am going to, instead of typing, I am going to copy paste bunch of stuff. Okay. It's just pasting sequence. As you have already noticed, it's a sequence of different things. Cars, USA, Chrysler, Dodge, Jeep, Germany, blah, 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 blah. Enter. Now it created a sequence, or Python terms, a list. It created a list of cars. Now let's create or make a data frame out of this, because this, so far, this step is still Scala, it's not Python Spark at all. Now let's convert it into a data frame. What? It's very simple. All you have to do is take your sequence, then type 2, and then hit tab. It will show you all the functions that are available with 2. So let's say df, you can pick it from here, it's right here, 2df, and then this. It's as simple as that. It converted it into your data frame. Now I want to see what is in my data frame, and what is my data frame name? Cars. Hit tab. Since you have two variables, it gave you 2. Now hit tabs. If you want to see something, just say show. Then it will show you whatever is in your data frame. As you can see, it figured out there are 4 columns. Since we didn't pass a schema to it, it just assumed those as the column names. And then it showed you nicely in a table like structure. Data frame is nothing but table, right? So what did we do here? We imported Spark implicit for our conversions. Then we created a sequence of tuples. Whenever you see open close braces, these are tuples, each representing cars from a country. Then we converted the sequence to a data frame. Then finally we displayed it using show. Pretty cool, right? I know. So that's in a nutshell what we did. Now, what if you need to pull data from a database? Well, we can do that here as well. Here's how to connect Spark to PostgreSQL. Why am I saying PostgreSQL? Because we already installed PostgreSQL. So let me go ahead and see if I actually have my PostgreSQL up and running. Okay, do you remember it? It's this. This is the user and the database, and it connected successfully. And if I hit this, it's showing. So my PostgreSQL is up and running. So let's go to our Scala. And how are you going to connect it to PostgreSQL? Simple. Again, val, because you are going to create a data frame. You are going to read a table as a data frame. PostgreSQL. And you will use something, the Spark session that you created, and you will say read. And what are you going to read? And you can say format. What is the format? It is a JDBC format. Since we are going to connect to PostgreSQL using JDBC, that's what. And then you will give you option, because you are saying JDBC connection, and JDBC connection needs what? A URL to connect to, and it needs the driver, the table, user, password, and all those things. So that's what we are going to write here. And I'm going to say driver, and you already remember the driver, don't you? Oh, sorry. Let me give URL first. And my URL looks something like JDBC. This is common, by the way. Then PostgreSQL. Any JDBC URL, not just Postgre, follows this one. Localhost. And for PostgreSQL, the port is going to be 5432. And then I don't have a database. I have a PostgreSQL, and then I created PyMetaStore, but that is for Hive. So what we will do is, where is this? Here, right? Let's go ahead and create a database, shall we? But I am as a user pSQL, and if I remember correctly, this user only has he is only the owner of PyMetaStore. I don't think he can create anything. So what I will do is, first of all, you need to sudo as post sudo u postgres. I think I gave it wrong. I don't remember it. Let me go back and check what it is. So this is the command. I am almost correct. And password will be whatever password I gave. Wrong. Okay. Yeah, now you can see I am querying as Postgres, and just type pSQL and you are logged in as a root on the PostgreSQL. Now you can create any database you want, any user you want. So what am I going to do is I'm going to create another database with the making the pSQL user as the owner. So let's do create database. I will just say Spark examples, and I will make owner as pSQL user. So it's creating a database and it made the pSQL user as the owner. Cool. Now I'm going to use that particular database I just created. And what is it? Spark examples. Examples. Okay. So that's what is going to be your JDBC URL. And then close it. And then what? Then we need to mention again option. Now let's give the driver. Let me know. And by the way, let me know. Do you guys prefer me typing these the code here, or should I already type the code offline and then copy paste it? Okay, however you want, let me know in the comments. I will pick your preference. If you like me typing here, I will do that. Or if you want me to copy paste already created code, then let me know. Okay, that is my driver. If you remember the video where we set up PostgreSQL as Hive Metastore, we have given these in the Hive file. And the next thing we are going to give is DB table. And these are common for any application where you want to connect to databases. Table name, well, we are going to read it, but we don't have any table in here. What do we do? That is a concern. So let's go ahead and create a dummy table here. But let's not do it as PostgreSQL. So let me exit it out of this. Exit one more time so that it won't be PostgreSQL. Yeah, let me exit. I want to connect as okay. Now let's create a table and add data to it. I just googled it and uh, Google. What was it? Google. I don't need this. Okay, let me edit them out. Google just gave me this dummy table and etc. I don't want all this fancy stuff. Okay, I think this should be fine. Copy it, paste it. It created the table. Now I need to insert data into it. So let me copy, paste this. Then it inserted 5 records into it. Okay, now if you want, so let's start from users. Okay, you can see that I inserted 5 records into this table. Now let's read this from our Spark application. So what is the table name? users. So let's go back here and let's do schema. What is our schema? I guess we have default schema, so we don't need to give anything. We will just say users is my table name, and then we need to provide password option, and then user, and then password, and finally you will have load. So this is the format, right? You will give the format. It is JDBC. If it is a text file, CSV, XYZ. Then give the URL, then give the driver, database table, and then user and password. User is psql user, and password. And by the way, it is going to be the same string even for MySQL as well, which we will see in later examples, later videos. What was the password? I don't remember. I am assuming it's this, but we'll get to know. Load. That's it. If everything is right, it will, but it didn't. So PostgreSQL, PostgreSQL.driver. Did we do something wrong? All right. Remember for Hive, we did something similar as well. Since it doesn't come with PostgreSQL driver, we downloaded it and put it in the lib, Hive lib. Similarly, we have to, I don't know if I have it in the downloads here. Oh yeah, we have it. So let's copy it and let's go to Spark. Here we don't have lib, but here we have jars. It doesn't come, similar to Hive, it doesn't come with PostgreSQL. So let's paste it. And it got pasted here. So let's go back. It still failed, assuming that when I started Control C. When I started Scala, it loaded it. Now let's do it again. Okay, let me rerun that. So whenever you run Scala, it loads the jars at that time. So that's why it did it. So anyways, now it successfully created the data frame and it is showing us the fields and whatnot. But this just created it. It's not showing you the data in it. If you want to show the data in it, what is the command, Pragnas? And by the way, how do you do it? Type the data frame name and tab. You don't have to type the full name. And then say show. That's it. It will show you whatever is in there. For some reason, user ID is null because it was an auto increment. And I guess even in our database, it is null here. You don't see because it was supposed to be an auto increment column, which we removed auto increment. So it didn't insert anything. That's fine. Anyways, whatever the data is in the database, it's showing, which is more than enough for us. It's as simple as that. See, connecting to a database is also very simple. This is Scala. If some of you were like, I'm not a big Scala fan. Well, if Python is your jam, Spark got you covered that as well. All you have to do is type PySpark and we don't get it. Okay. So let's see. I think we need to run the. I think this is creating me a headache. I'm not liking it, to be frank. Where is my favorite file? What is our favorite file? The bash rc file. Let's go. Or yeah, I can do that. I guess. Let's do it. Oh, okay. Now it should have loaded it and type Python. What did I do? That was my function that actually loads all my Spark related variables into environment or environment variables. That's what it happened. Okay. Once you do this, you will see a similar message and prompt as that of Scala. Okay. Now, Do we have those code lines? We don't have those code lines. That's fine. Let's try to create the same thing that we did with Scala. What is that? Let's create the list that are sequence that we created using Scala. But with Python, see here, I am not giving a variable val cars. Python automatically infers the data type based on the data. And here you are creating a list instead of using the word seq. That's how you create a list in Scala. In Python, you use a square bracket and then you have tuples inside it. Enter. And see, you will see so much similarity between these two. Now, I need to convert this into a data frame. In Scala, we have did two data frame. Here, you have to do Spark, create tab, hit tab, it will fill you for you, and then give the variable name. Now it converted that into data frame. And if you want to see this, cars, then underscore tab dot show. Same command between Scala and Spark. Then it will show you whatever list you created in the data frame format. It's as simple as that. Again, we created a list of tuples, turned it into a data frame and displayed it. So that's Scala and Spark. Let's configure and run applications with Spark Submit. We have done it in previous videos, but let's do that again. When will you use Spark Submit? If you want to run a self-contained application, not something that you want immediate feedback. You type this, you get immediate feedback. But if you want to put all of this into a single script and run that, how do you do that? You will use Spark Submit. And Spark Submit, a typical example I will show you, which looks something like this. Right? You have the Spark Submit and then the deployment client, master is local, class is Spark Spy, the Spark Spy example if you want to run it from here. And then where is that jar located? The Scala jar located here. Got it? This command is launching a job that calculates Spy. And if I had to run this, I can run this because we have everything in place. But I need to go somewhere here. And let me run Spark. Okay, now let's run this. Okay, what is it completing about? Deploy mode does not exist. What? You know what? Since everything is in a single line, okay, I think this should be fine. Let's try it one more time. Okay. Oh, sorry. I have made another mistake. Let's go here. I don't know how. Maybe while removing that, it was client. Failed to load class example Spark Spy. It does not exist. Maybe this version does not exist. So let's go here. Let's make sure it exists. Spark jars. We are looking for Spark Pi. Is it this folder? No, I think it's in the examples if I'm not wrong. Yeah, it's in the examples jars. Examples jars. Oh, we don't have that. Haha. Oh, it is there. Yeah, we have it. Maybe it's not 2.12. It's 2.12356. Never mind. And it's from a different example. So let's go 5, 6. And you will get the pi value at the end of the day, right? Um, so that's that. And if you want to see less log noise and only show errors, right? Because here you are seeing info and whatnot, you can edit log4j2.properties file in Spark conf directory. So for example, if I go here, conf, all right, here we will have a file called log4j. Copy, paste, rename this, edit it. Okay. Here we are going to do a couple of settings. We have this as info, that's why it's showing info message. If you don't know anything about Java message types, you will have uh, debug or trace at the highest level, then debug, then info, then warn, then error, then fatal. We don't want info. I think error is fine for us. So let's change this to error. Okay, let's save that. And oops, I don't know where we went. Now you see, you don't see any info messages whatsoever. Instead, you will only get the pi value, because we said only if there is error. Error covers first is fatal, then error. So anything fatal or error, it will be displayed. Remaining, it won't. So that's the magic that we did right now. Okay. Now Spark, it gives you tons of flexibility for tuning resources like CPU, memory, and more. For example, when you saw, I don't have that here, but you saw the executor cores option, right? That lets you configure number of concurrent tasks per executor. And if you set executor memory, it will let you choose amount of RAM for executors. Then you have number of executors, which is the total number of executors you want to use for that particular application. And then you have something called driver memory, which lets you use RAM for the driver. Okay. And you can enable dynamic allocation to so Spark automatically adds or removes executor based on the workload. All this we will learn in the intermediate Apache Spark Masterclass. This is beginner Apache Masterclass. Once we finish this course, and once if this course is successful, if you guys like it, and if you blow it up, then I will start the intermediate Apache Spark Masterclass, where we will cover performance tuning. We will cover different deployment modes, Spark streaming, and all that awesome stuff. If that blows up, then I have advanced Apache Masterclass, where we'll cover machine learning and all that awesome stuff. So that's about the tuning Spark for performance at a very high level. I didn't even scratch anything. And remember, always don't hard code cluster configurations in your code. Use external configs for external configuration, or pass parameters at runtime via the Spark submit. Remember that, very important. Do you want to run your own Scala application, or do you want to write a Scala object, then compile it and then submit it? You can definitely do that. How do you do that though? Well, you can write your own functions in Scala, just so you know. I'm not going to show that right now. That will be covered as part of um, our intermediate, even creating functions. I will just show you an example. This is how you create a function. Okay. And then you will compile it with Scala, then you will submit it. Right? Object functions will create the function. Then you need to compile it with Scala using this particular command. And you are going to submit it using Spark submit. Then you will have this function, and then you can use it. Got it? If you want to see how to do this, okay, let me show you that quickly as well. We did that. And once you do that, the next step, what did I say? We need to compile it. We compile it using this. And you do that from any place like this. And by the way, okay, my indentation is wrong. Indentation. So here's the modified code. Let's save it. Okay, let's go ahead. And we are compiling it into functions.jar in this folder itself. My root directory or home directory itself. Now, what is my next command? I said you go ahead and run this with Spark submit. Okay, the output is 3. Basically, the code that we have written, that's what it does. Okay, aggregates, adding those two. It's as simple as that. We just added 2 numbers on a Spark clusters, and congratulations, that is a big deal. Trust me. If you have to write the same thing using MapReduce, you would have scratched your head like, why am I doing? What am I doing? So that's about this. If you are curious about how Spark applications actually work behind the scenes, you ever wondered what a Spark session is? We are hearing that word a lot. Or how you can peek into Spark's internal settings, or even how to create your own Spark applications from Spark from scratch. Well, this is the right place for that, isn't it? We are going to break down Spark's core concepts like sessions, jobs, tasks, and more in plain English right now. And of course, I'm going to walk you through some hands-on code, just like whatever we are doing so far, so you can follow along step by step. Let's get started. Now, first of all, we need to understand the Spark application terminology, because that is very important for you guys even to crack the interviews. Before we start building big data magic with Spark, let's know some key terms, shall we? One is the Spark application. I've been telling you, or at least saying Spark application a lot. What is that? This is just your code that uses Spark's APIs, like something you write in Python or Scala. When you launch it, it runs on a cluster with a driver and executors. Basically, that's your Spark application in a nutshell. What is a Spark session? Think of this as your entry ticket to the Spark universe. It lets you talk to Spark, it lets you submit jobs, and it manages that data. That's what a Spark session is. And what about tasks? Tasks are the tiniest pieces of work. Spark splits your data into lots of these so-called tasks, and each one gets run by an executor. And what about stages then? If tasks are this, think of stages as groups of tasks that run together. Got it? Tasks are at the lowest level, which are, you know, Spark splits and gives it to these tasks. And a group of tasks that run together is called a stage. Whenever you do something that requires shuffling data, for example, like when you want to reduce by a particular key, or when you perform a join, Spark creates a new stage. And finally, jobs. A job is just a bundle of stages. So it's a bigger chunk of work, like running a query or writing some data. So at the highest level, you have jobs, and then that is divided into stages, and stages divided consists of tasks. Let's visualize this with a real world example. If you want to process, let's say, a giant CSV file, Spark will split it into tasks, and it will organize them into stages, and then it will handle the execution as a job, all controlled by your Spark application. And what did I say about Spark session? It is your main point of interaction with Spark. Spark session, right? You will create a Spark session in every Spark application you write. And if you are using Spark Shell or PySpark, it is automatically created for you. You don't have to worry about it. And in Scala, what did we do? If it is from Spark shell, it automatically created that for you, right? So you don't have to worry about it. But if you are writing your own application, then what will you usually do? You will import the Spark session, and then you will create the Spark session by using a Spark session builder getter create. So let's see how that works. Okay, so let's it created, right? So let's do this. Let's import org.apache dot spark dot sql dot spark s capital and session. Remember that. Okay, we imported that into this session. Then you can create something called current spark session. So we are accessing the spark session that is created here. Dot builder dot get or create. We are telling if it is there, get it, otherwise create it. And finally, we are printing whatever we just created. Oops, what did I do? Print. Oh, there's too many. Okay. Now, as you can see, it did that. So all you did was getter. Where is it? Getter create. Since it's Spark shell, it will get it, not create it. If it is something like glue job, then it will create it for you. If you haven't created a Spark session in that particular application, you can again, as I said, you can get the active Spark session for current thread returned by the builder. You can use get active session method as well. All you have to do is you have the Spark session, then you will do dot get active session. And you can also create a new or another Spark session using new session method. That will be similar. You can create a variable, then Spark. I'm not going to explain that much, but you can say val some xyz variable name spark dot new session, and then you can print it. That will create a new session instead of whatever session you have here. And let's do the same in Python. Like, let's get the current configurations via PySpark configurations. How do we do that? Well, let's say configurations. Okay, I don't know why this is not typing. Okay. And then we are going to say Spark. We are going to access Spark context. That's what is going to give us our configuration. Capital C. Then we are going to say get all. Now these configurations are loaded into this variable. Let's print that variable. And you can see we got all the configurations of this current session, right? It printed Spark app name, master, warehouse directory, and many more. You can also set Spark config values on the fly. You have seen some of the config values being set in the site files, right? Conf, we went into the Spark directory, and in the conf, we have set these configurations in these files, right? But these are cluster wide, but you can set them here as well on the fly for the session. Let's see how to set some of them. Spark, if you want to set anything, you can use this one. Spark conf set. And what is the configuration that I want to set now? Spark SQL shuffle partitions. This is one of the configurations. You will learn about this more in later on, but I'm going to tell it to change this to 30. Now it's set. And one other useful thing you might set is the app name. Spark app name. Let's say, okay, that's how you set it. But if you want to get these config into your code somehow, you can do that. Conf, instead of set, you will say get, and then you will give which configuration you want to get. I'm going to tell it, give me the app name, and it is going to give you that app name. It's as simple as that. Right? This is super useful for tuning performance or customizing your job, whatever the reason it might be. And then we have the Spark session object. What does it do? It lets you explore your data catalog. For example, like see what databases and tables are available in your Spark. What is the command you might be using? Let's go to Scala for this one. Spark, and then you want to access catalog. And what do you want to do? I want to list databases. You can store this in, let's say, databases. Enter. Okay. Spark not found. What is going on? Oh, never mind. I am in Scala. I am not in Spark shell. Control D. I did a mistake. Spark shell. For a minute, I was like, no, don't do this. Okay, now we have our Spark session. Let's go ahead and do the same. Spark catalog list D, and hit tab. It is going to fill the rest for you. Now let's say, wow, it's going and searching, I guess, behind the scenes. Let's say show. Now we did the show, but as you can see, it truncated some of the text. If you don't want that, there is a property here. You can set it false like this, or by default, if you set to false, it will take it for a truncate and it will not truncate anything for you. So it is showing you all the databases that are under Spark and where their location is. Interesting, isn't it? And you can repeat the same for tables as well. Instead of list databases, you will say table. If there are any tables, it will list them. If not, then it is not going to print much. There are none. These methods that we only saw two, but they are great for data discovery and introspection, especially in collaborative or large environments. And since we are using Spark shell, we already know that Spark session is already created for you as Spark. Remember this, these are like interview questions. Spark shell already has Spark session created for you as Spark. That's what we accessed here, correct? And if you want to see Spark version, what is the command? Spark.version. It will give you what version of Spark it is. You can, I guess, see it when you enter Spark shell, but I'm just saying for some reason in your code, if you want to use the version, you can access it by doing this. Let's now look at how to create a Spark application from scratch, shall we? We have done this, but I didn't explain you much. But let's look at it both in Scala as well as in PySpark. So what do we do first? We have to import certain things, isn't it? So now let's try to do it in Scala first. So the first thing we import is Spark session. By the way, this I am doing it in the shell, but I don't want to do it in the shell. So let me do this. Let me copy that and let me go here. And let me click here. So this is, imagine this is your Spark application, programmatically. I mean, not in the Spark shell. Spark shell, you execute each command at a time. But if you want to execute an application externally, you write it in a and put it in a file. Since Spark session is by default available in Spark shell, it is not by default available in when you are executing through a programmatically. So you need to import it and create your Spark session. Got it? And since we are writing an application, I will what I will do is I will go to our friend IntelliJ. Let's open that. Cut. Go here. Let's open there. I mean, you can run it from here as well, but I need to build it as a jar and then execute it using Spark submit. But if it is here, all I have to do is go to this, not there, Scala, new Scala file. And I'm going to call this, what should we call this? New Spark session. If you have never seen, these classes are created with camel case. So that's what I'm going to do. Enter. So now it created one, but I mean, I did I say class? No, I don't want to create a class. Instead, I want to create something like this. So let's close this. Delete this. Where is delete? Here we go. Yeah, that's fine. Right click, new Scala. Okay, how? What is it? It's an object. Should I just create a file? And I will name this new spark session.scala. Okay, that's fine. I don't know why it has that symbol, but we will see in a minute. Let's do import. Or should we copy it from here? Or I don't know. I will just type it for now. If you don't want me to type it, let me know. As you can see, it will suggest me code which is useful when you are learning. Object, new Spark session, extends. Don't worry about the code and all. As I said, you have a course called Scala for beginners. You can use that code course later on. I am going to upload it after chapter 3. Using that, you can learn about basics of Scala as well as Python. So what I'm trying to do here is I'm trying to create a Spark session here, and we are going to use our builder method. Okay, start master. Master is where you are going to tell it whether it is a local cluster or if you have some other cluster on some other URL, and then you give. This is optional. If you want, you can give. If you don't want, you can ignore this. It's not a mandatory one. The app name, and then you are going to say get or create. If there is already a session, get it. Otherwise, create it. Now you are going to do print ln just to see your Spark session that is getting created here. And you can also print ln something like the Spark version. If you want to print version is Spark.version. Remember this that we used previously? And you can go ahead, Control S. And I hope it uses the same settings that we had previously, which were this. I guess it doesn't have it, or is it in the edit configurations? I don't know. Let's see. I want to run this file. If it fails, we know that it doesn't have that setting. Then we can go ahead and modify the setting. That's not a problem. Yeah. So let's do that. It's okay. Let's go here, edit, run with parameters, and then let's go this, add VM, copy paste that, apply, run. Okay. It ran, and as you can see, it initially print that, and then the second one that we wanted to print is the Spark version is and the version. Cool. So both work. This is just an example of a Spark application that you can create in Scala. Right? We imported the Spark session, then we built a session with 4 local threads. This 4 means you are creating 4 local threads, and then we gave a custom app name. Then we printed the session and Spark version. Now let's do the same thing in Python. And did we not set up any IDE for Python? I mean, I know we have Jupyter and whatnot, but I wish we had something like this. Okay, that's fine. So let's go here. And what do we want to use? Do we have? Yeah, we have Jupyter. Let's go start Zeppelin if we can. Give me a minute. So let's go here and let's go to Zeppelin and let's this one. Okay, it looks like it started. But in one of the video, I wish we had set up not data grep with PyCharm. Maybe one of the video. We'll see. So let's go to first node that we had previously. And let's remove this. And let's put the interpreter. I will say PySpark. Okay, what are we going to do now? Let's write the same thing, repeat the same thing, but using PySpark. Shall we? It's going to be something similar. Import PySpark. That's fine. Let's see if it is going to import it or not, or if it is going to complain. Oh, wow. That's taking. Okay, it's finished. Okay, it's fine. It's working. And we are going to say from PySpark. It is suggesting me now. Then we have SQL, and then we will import from here Spark session. Okay. Whatever we did for the other one, it's different, a little bit different here. And once we do that, what do you do next? You create the Spark session. In Scala, we said val Spark. Here, you don't have to give the val. And you are going to say Spark session dot, same thing, builder dot master, similar to that, and local, how many threads you want to give. In this case, we are going to give 4. And by the way, don't forget to give quotes here. Dot app name similar to Scala again. I will point things when they are similar and when they are not. And then finally, get or create. That's it. Then, as usual, let's print this particular Spark session and then also print similar to our Scala. Spark version is Spark dot version. Same command. Now, if I run this, it should print my session, as you can see, as well as my Spark version, which is 3.5.6. It's as simple as that. I don't use this. Usually Jupyter you get when you right click, uh, you can clear whatever is in there. That's about it, right? Once you got a Spark session, you are ready to do data analysis, run machine learning, or process huge data sets. If you have ever wondered how Spark actually processes your data behind the scenes, or what terms like transformations, actions, and lazy evaluation actually mean, then stick around. These terms, remember them, they are very important in your interviews. Today, I'm going to break down some of the most fundamental Spark concepts so you can start thinking like a true data engineer in this particular section of the video. Let's start with a quick question. Have you ever changed a file only to realize you can't get back the original? We have faced this issue several times. I have done it especially. Well, Spark's core data structures. Remember, what are the Spark's core data structures? RDD and data frames. These are designed to avoid that problem. Using what? Something called immutability. What does that mean? It's the power of unchangeable data. Well, what does that mean? Well, I'm going to explain. Don't worry. In Spark, data structures are immutable. That's just a fancy way of saying once you create them, you cannot change them. Remember this? Immutability means once you create them, you cannot change them. So when you do something new to your data, Spark doesn't alter the original. Instead, it creates a brand new version. So let's say you have a say um, file1.txt and you modified it. Maybe you removed some data records from it, you added records to. Instead of modifying it in the file1.txt, it creates you a file2.txt. I mean, not a file, but I'm just telling you, it doesn't alter the original, it makes a brand new version. You might be asking, why? Because this guarantees your data is safe and that every operation is trackable. No accidental overrides here. That's basically what immutability means. Then let's learn about what are transformations and actions and what are these two things. In Spark, all operations are divided into these two. Either they are transformations or they are actions. Well, when do you consider an operation as transformation? Remember, transformations are like setting up instructions for Spark. They take an RDD or data frame. Don't worry about what RDD is. We will learn about it. Or data frame, they will take it as an input and then they will return a new one. But here's the cool part. They are not run immediately. What does that mean? Well, let's see an example. Maybe you will understand more when you see an actual example. Shall we? And you might be asking, why not copy this code from here and create the Spark session? Well, we are going to create an RDD, which is an old entry, old way to creating RDDs. So you would have to use Spark context, not Spark session. So for that, we are going to do from PySpark, we are going to import Spark context. And then we are going to create a context. Sorry. And the old way is to just give you how many threads you want. So star. And then write the app name. And we are going to create our RDD, sc dot parallelize, and so give some random numbers. 1, 2, 3, 4, 6, 10, doesn't matter what. So give. Now, once you do this, and let's call this RDD1 because we are going to create multiple RDDs. RDD2, and we are going to use RDD1, but we are going to filter some data. Filter, and we are going to write a lambda function, lambda. And RDD3, we are going to perform some map on this one. Don't worry about what I'm writing. I will explain you, and you don't have to understand this at this point. All right. So we have this. So what's happening here? First, we created RDD1. I mean, we created Spark context, and using Spark context, we created an RDD1 with some random numbers. And then we created RDD2 by filtering out any values greater than 5 from our RDD1. So RDD2 will only contain 6 and 10, whereas RDD1 will contain all this. And then we made RDD3 by doubling every value in RDD2. So we squared each value. So it should be 36 and 100. Now let's go ahead and print them. Then you can see them with your as RDD1, and I will say RDD1 dot collect. Collect is an action which we'll talk about later on, but for now just go with the flow. And let's say RDD2, RDD3, 2, oops, 3, let's run it. What is going on here? Multiple contexts. Do I have multiple contexts? I think when we ran this one, it already created a Spark context, I guess. So when we try to create this again, it is complaining. So instead, what we will do, instead of doing this, we have created Spark here, right? So let's click Spark dot Spark constant context. Now you can run this as usual. And it's complaining. Never mind. I did a mistake. So let's remove. It's small s. Okay. So since this is the new way to do it, this includes the old way Spark context. That's why it did that. Now, as I mentioned, the RDD1 contains everything from here, and RDD2 is built by filtering on RDD1 greater than 5, only this. And this, this is not square. Square is double star. It's multiplying by 2. It doubled it and made 12 and 20. Okay. So as you can see, if I remove this and if I run this, nothing happens when you write these codes. And even if you execute this, Spark will record what you want to do, building up a sequence of steps, which it calls a lineage. This sequence of steps is actually represented as a DAG or directed acyclic graph, which is a kind of roadmap Spark will later use to optimize how it processes your data. Okay, it doesn't do anything at all. This is called lazy evaluation. So Spark waits until you call an action. So if nothing happens yet, when does Spark actually process the data? Only when you run an action. So these are transformations. Until and unless you call an action, Spark won't execute all the transformations that you write. This behavior is called lazy evaluation. This is an interview question, remember it? This is lazy evaluation. Spark waits until you give it a final instruction so it can figure out the best way to process everything efficiently. Now, we had this one, but it printed. So tell me, what is the action here we are doing? You guessed it correct. Collect is the action. When you are collecting, you are telling it, go execute all the transformations and give me the result. Got it? Now you know what transformations are, what actions are. There are different actions, different transformations. We will learn later on. And in transformations, there are two types. One is narrow and another one is wide transformations. Remember, not all transformations are created equal. Some are narrow, others are wide. Well, what does narrow transformations means? Narrow transformations are the ones where data doesn't need to move between partitions. Think of it like doing all your edits on your own copy of a document. Okay, that's narrow transformations. If you are wondering why I'm not explaining RDDs and partitions, whatnot here, I don't want to. Here I just want to explain you or give you a overview of our first app and then explain you these terms, but not go in detail. We have a dedicated section for all this, so don't worry about it. Okay. And some of the narrow transformation examples are which we already used here, which is map. Okay. And remember, narrow transformations are the ones where data doesn't need to move between partitions. It won't move between partitions. Whatever data is in your that partition 1, it will remain the same. Your transformation is not affecting anything. For example, all you are doing here is multiplying by 2. Do you need to collect all the data from different partitions here? Of course not. Map, flat map, filter, union, these all are examples of narrow transformations. So if you use filter, you are just processing data within the same partition super fast. Whereas wide transformations, on the other hand, are a bit more involved. Here, Spark has to shuffle data between partitions, which can mean more network and computation time. And again, what are partitions? How data behind the scenes Spark partitions? We have discussed that in one of the chapter 1 videos, but I'm going to walk you through that later on as well. Don't worry. What are some of the wide transformation examples? Group by key, join, distinct, aggregate by key, repartition. When you do a group by, obviously you need the same value which is in all the partitions, then you can do the group by, right? So for that reason, it shuffles data between partitions. Imagine partitions in the sense, if you have a file 1.txt, it will be divided into different partitions, right? And depending on what kind of transformation you are doing, it will be like, do I have to go to different partitions to get this answer you are asking? Then that's called shuffling. If you are not, then the transformation is just a narrow transformation. In my data is in partition 1, and whatever transformation I am doing, it is going to be applied on partition 1. I don't need data from other partitions. Whereas when I am doing a group by, of course I need the same data from all the partitions, and then I will do group by, etc. Okay. So what is an action again? An action is what finally tells Spark, okay, let's do this. Action returns a value. It does not return a new RDD or data frame. When you call an action, Spark runs all the transformations you have set up before it using the most efficient plan, which is what you have seen here, this collect. As soon as Spark sees collect, it kicks off the actual work running through all the transformations you have chained up to this point. Some of the other actions include count, first, min, max, stop. All right. So let's wrap up this video here and let's recap what you learned today. You have just learned how to use PowerShell for Scala as well as Python, run commands interactively, connect to databases, tune resources, and run your own applications. PowerShell is a powerful way to experiment, debug, and learn Spark quickly. So open your terminal and try all the commands yourself. Whatever commands code I have written in this particular video, it will be available under our what is it? Classwork. So go to this website. This will be in the description. Don't worry about it. Okay. Go to courses, Spark. I hope you are doing all the quizzes. Quizzes are right here. We are in chapter 3 right now. I haven't put yet. I have only uploaded till here. I will be catching up by then. But Chapter 3 quizzes should be here. Do that. Then interview questions for chapter 3, similar to chapter 1 and chapter 2. They will be here. Do that. And then what I'm talking about is the classwork, which you can see here. When you click here, and if you click chapter 3, the classwork should be here. Classwork will contain all the code that I executed in the video so that you guys can write it on your own. Don't copy paste the code from here. Type it. When you type it, you will learn it. Trust me. Don't copy paste. Instead, type it. I have put chapter 2 classwork here. So all the comments that I used in this particular episode, I have went ahead and put it there. You will see chapter 3 by the time you are watching this video. And guess what? We are going to have something new. Homework. You might be asking, right? You don't see anything here because I haven't created this page yet. It will be similar to classworks, but that is going to have homework, which means I'm going to ask you questions. Based on that, you need to code it. And I'm not going to ask out of syllabus. I'm going to ask questions only those that are covered in this video, topics that are covered in this video. Okay. So do it. I'm going to give you the solution as well there, but I want you not to check it until and unless you tried the code or try to solve the homework on your own. If you check the solution, then there is no point in you watching these videos and doing it, because I want you to learn it and follow what I am telling you and do it as is. Okay. Homework, look at the question, then try to come up with your own code. Then look at the solution, compare it, and let me know in the comments if you were able to do all the homeworks. Each episode will have 15 homework questions similar to our interview questions and quiz questions. So do them and let me know in the comments how many did you do, and if you have any questions on any of those exercises, if you need help, let me know in the comments as well. Got it? And what did we learn here? What a Spark application is and how it's structured, what the Spark session is and why it's your main entry point for using Spark, how to view and tweak Spark settings both at launch and on the fly, how to inspect databases and tables using Spark catalog, and finally how to create your own Spark application in both Scala and Python. Then you learned about immutability, which keeps your data safe and operations trackable. Then you learned about transformations, which set up your data pipeline, but nothing happens until actions trigger Spark to process everything. And thanks to lazy evaluation, Spark can optimize everything you have planned before it gets to work. Now it's your turn. Open your IDE or notebook or Spark shell or PySpark. Try creating a Spark session. Poke around with the configs and maybe even start building your first real Spark application. If you want to get really good at Spark, understanding these ideas is very important. These are the key. Try them out in your own Spark shell and experiment with different transformations and actions. You will see the difference right away. Don't forget to like, subscribe, and drop your Spark questions in the comments. Happy data crunching, happy sparking, and I will see you in the next one. Peace out. Love you all.